Welcome to Epicenter, the show which talks about the technologies, projects, and people driving decentralization and the blockchain revolution. I'm Friederike Ernst, and today I'm speaking with Zac Williamson. You're not going to launch this thing without decentralization, right? Kind of like you want a decentralized sequencer and provers.
We're not doing this out of some moral crusade. We're decentralized because we need to be. We can't be centralized. We'd have to build in a backdoor. We don't want to build in a backdoor. Backdoors are really bad.
You want to use things that are battle tested as much as you can, right? Building novel things kind of means having to build new systems, but trying to possibly fall back on proven systems.
There's no such thing. There is no fallback. We are the first. Aztec will be the fallback for future generations of private cryptography. Once we get beta, we will be much more comfortable making claims about its security. We'll be much more comfortable with people putting large amounts of funds in. But until then, it's going to be a risky protocol.
I'm Friederike Ernst, and today I'm speaking with Zac Williamson, co-founder and CEO of Aztec, a layer 2 network building what it calls programmable privacy for Ethereum. So Aztec was once known for private transfers, but a couple of years ago, the team did something that very few projects actually dared to go through with. They shut everything down and rebuilt from scratch. The new Aztec promises fully private smart contracts, not just private balances, but private logic, computation, identity, while still remaining compatible with Ethereum's public ecosystem. We'll dive into all the details in just a bit.
This episode is brought to you by Gnosis, building the open internet one block at a time. Gnosis was founded in 2015, and it's grown from one of Ethereum's earliest projects into a powerful ecosystem for open user-owned finance. Gnosis is also the team behind products that have become core to my business and that of so many others, like Safe and CowSwap. At the center is Gnosis Chain. It's a low-fee layer 1 with zero downtime in 7 years and secured by over 300,000 validators. It's the foundation for real-world financial applications like Gnosis Pay and Circles. All of this is governed by Gnosis DAO, a community-run organization where anyone with a GNO token can vote on updates, fund new projects, and even run a validator from home. So if you're building in Web3, or you're just curious about what financial freedom can look like, start exploring at gnosis.io.
Zac, thank you so much for coming on again.
Thank you so much for having me on. It's a pleasure to be back here after all these years.
Yeah, absolutely. Yeah, you were last on Epicenter when Aztec was still running its earlier version. Tell us what's happened since.
Yeah, so back then I think we were on Aztec Connect, which was a continuation of the world's first fully private rollup. So it was a layer 2 network where you could send private transactions and use our network effectively as an anonymous proxy into Ethereum DeFi. So you could talk to something like a Uniswap or an Aave contract and have the Aztec smart contract act as your proxy. Then the result of that DeFi interaction would come back into the Aztec network, and then you could take your claim of it privately. So back then, that was the most advanced thing we could do with the technology that we had available at the time. Something we called TurboPlonk was an extension of the original Plonk paper that we put out in 2019. But that was the Aztec Connect was never really the full aspirations of the network. We built it because we wanted to demonstrate that privacy was possible and useful and needed. What we've wanted to do all along was create a private smart contract ecosystem. So one where instead of just doing transfers or talking to DeFi, you can have a sharing complete smart contract language where you can write your own state transition functions, and describe the logic of whatever protocol you desired, but with private data as a first-class primitive. So yeah, that's what we decided to build, I think, shortly after our first conversation.
Why did you decide to kind of rebuild this completely instead of just iterating on the old system? Because, I mean, obviously people were already on there. People were using it.
That would have been nice. We had, I think it was 60,000 monthly active users. It was and growing quite rapidly. The challenge was that Aztec Connect was built from scratch with the latest technology we had at our disposal. No one had really built a fully private rollup before. So we were figuring out a lot from the first time. And in hindsight, we made a lot of architectural missteps that we wanted to correct. We didn't really have a viable path to iteratively upgrading Aztec Connect to add programmability into it. Everything changed. The semantics of how you create transactions, the cryptographic proving system that you need to use, the node software and its interface and its API. We quickly realized what we wanted to build was unrecognizable compared to what we already had, and that we needed to take those learnings and that institutional knowledge and recast it. But we didn't see a viable pathway to iterate Aztec Connect, unfortunately.
Tell me about the moment that you guys realized this. So kind of obviously kind of as a builder, as a founder, you get attached to what you've built, right? Kind of like it's your baby, and kind of like the users kind of you feel close to them even if you don't actually know them personally. Kind of you are somehow indebted to them, right? So kind of you have some sort of tell me how that went down.
Yeah, I still feel like pang of guilt whenever I talk to somebody and they say, "Hey, I use Aztec Connect." I'm like, "I am so sorry. I'm so sorry.
That I use Aztec Connect, so
I'm so sorry." It was tricky, It started with we had some internal conversations. Basically, there was this inciting incident where we made some research breakthroughs that made the full programmable version possible, and it was an evolutionary process. A lot of others also spent maintaining this node software. We didn't really have the ability to really launch this, what we were calling Aztec Free project. There were some people, we were having discussions, so people were like, "Hey, like maybe we need to kill this." Then that started turning into internally like quite an active discussion, and yeah, like eventually it was ended up as me and Joe in a coffee shop having a very long conversation about the future, about what we wanted to do. We came to an agreement that we need to. There's no way that we can serve both Aztec Connect and Aztec 3. One needs to go, and it should be Aztec Connect. But it was a tough conversation.
Which one of these kids do you think we should kind of put up for adoption, sort of?
Yeah, everyone says they love their children equally, but maybe deep down, there's
like one of them is Aztec 3.
Don't want to acknowledge. And then we're like, yeah, okay, one of our kids needs to die. Prepare the sacrificial altar.
Okay, maybe let's move into kind of like more theory territory. So one of the kids is somewhat alive again. So tell us kind of like what's live now and what's still being built.
We're calling it Aztec now. We're releasing, it's not Aztec 3 anymore, and it is alive. It's on public testnet. It's fully decentralized. You can deploy contracts to it today, send transactions to it. I think is it playground.aztec.network, I believe. And we are currently going through a audit process, and doing some last minute adaptations to it. To get it ready for mainnet, which should be happening early next year.
Exciting.
Very alive and kicking. Like now the main focus internally is basically focus on the DevX. We launched the testnet earlier this year, and we're basically transitioning the organization from a place where the goal was just get it working, whatever it takes, just get it working, to one where a mandate now we need to make it good, easy to use and develop for. So that's still a work in progress, but by the time we hit our launch next year, that should be all squared away.
Fantastic. So maybe let's talk about the way this thing is architected. So kind of there are a couple of core design choices that you guys had to make. And I think maybe it's easiest if we kind of walk through them one by one. So kind of the first I noted down as kind of decision to kind of have a hybrid public and private execution situation. Tell us about that.
For sure. Yeah, well, that came out of, again, like I think Aztec Connect is existentially important for us, because this came out of Aztec Connect, like a learning that we realized, okay, so with private state, the way currently is, at least if you don't have FHE, if you don't have advanced NPC like Taseo's stuff, which we do have, but not yet like critical level. At the critical level, all private data is encrypted, and you need to use a UTXO based states model to do that, like Bitcoin, where instead of having an account where you have balances that can be modified, you have individual discrete objects of state in your database, and these things have owners, so that your token balance is made up of lots of these different nodes in your database. The reason you need this for privacy is because if I have an encrypted balance and you send a transaction that changes my encrypted balance, well, if that balance is just one piece of data in the network database, then you can see it change, and therefore you can see the transaction graph.
You also need the entire state, right? Because kind of like in an account model, you don't actually have the account balance noted down anywhere. Kind of like you actually have to walk through the entire history of the state in order to kind of arrive at.
You do, but in an account-based model, you still in the state tree you do have like a variable, a state tree which will have your balance. Finding it might be tricky, but it's there. And so when a transaction changes it, you can see that, and that's not okay if you're private. So instead we have the model that really is Zcash and Zerocoin propagated, where you have individual bits of state. They're encrypted by an owner, and they can be created or they can be destroyed. And that's how you modify them. You destroy it and then you create something new. The reason why we do that is that the records of destroyed notes and the records of created notes, you use different encryption algorithms for them, so that an observer can't link the two. So if I destroy 2 of my notes, create 2 new notes, maybe one of them is owned by you, one of them is owned by me. The only thing an observer can see if they look at the network is that 2 notes were created, 2 notes were destroyed, but they don't know what they are and they don't know how they're linked. Therefore, it's private. However, the problem there is, well, if it's private and if it's encrypted, how do you do global state? As in, take Uniswap as a smart contract. If you have an AMM, a liquidity pool, well, you need to know what's in the liquidity pool so that you can perform your liquidity calculations. And like a token which has a total supply, how do you update that? If everything's owned by somebody who holds a decryption key, you can do it via MPC. You can do it, which is very challenging. Or you can kind of skip the problem entirely by having this hybrid state model, where some information you can make private and some information you can make public. So in this context, the simplest way on Aztec to make an AMM is, well, you make the AMM fully public, so you can see the token values going into the market. You can see the trades that are happening, but you can't see the identities of the participants. So I could put some USDC into an AMM, take out some ETH, and people can see what's the prices, but they don't know it's me. In many ways, that kind of system can get you the best of both worlds, where you get privacy for the user, but transparency for the protocol, which often can be very important to understand that you've not been cheated, you've not been manipulated. But you can, sorry, I'm rambling here a bit of a monologue. With advanced MPC shared state primitives like Tatseo, which is present on Aztec, you can create fully private contracts if you desire it. It's just right now, the infra to handle that is less built out than it will be in a couple of years.
I understand that there are public contracts and there are fully private contracts. Can I build something that's in between, so kind of that I can kind of share with a select group of people, so kind of like my own AMM pool that I only allow my besties to kind of trade on, sort of thing?
The code for private contracts does not have to be published. If you need the code if you're going to send a transaction, but it's not published by default. So if you want, you can just share that code with a select group of people, have a whitelist, so that you can basically have this completely isolated suite of smart contracts within the Aztec network that nobody else knows about. Can't remember I don't think we've actually added it as a primitive yet in our protocol, but it will happen in an update where you can encrypt smart contracts so that you don't just need the code, you need a decryption key if you really want to go that direction. You can also have hybrid systems in another way, where you could have a single smart contract that has both public and private functions. So a canonical token contract is like this, where you can shield tokens, but you can also unshield them, and you can send them around publicly. And if you want to go even further, you could only share the private parts of your contract with a select few group of people if you really wanted to.
Okay, walk me through. So at the face of it's kind of like, it sounds very sensible, but kind of as an engineer, it sounds tremendously complicated to kind of construct something like this. Walk us through kind of the challenges and the solutions that you found to them.
Oh, so many challenges. Because it's not just the difficulties of building it, but also it's creating abstraction layers that allow building on it and for it to be relatively easy and straightforward. The goal is that for any Web3 engineer to be able to write and deploy smart contracts, you don't need to know cryptography or weird complicated semantics around privacy. I mean, I guess the very first problem was just technological, as in, if you have private transactions, then each transaction itself is a zero-knowledge proof. And so how do you make that proof? Because normally if you look at things like the Zexi paper and early attempts at creating private transactions, they're very unintuitive to a developer or engineer. The idea is that instead of having code that modifies state, you have state that that comes attached with some code which defines how that state variable is created or destroyed. That's how it used to work, and it's like, it's not intuitive, it's messy. So we needed to take those models that existed in the literature that you could create snark seconds for, and actually go, okay, no, we want contracts, and those contracts can call other contracts, and these contracts can manipulate a database of arbitrary state. How do we do this? So we had to come up with some very novel cryptography to even pull this off, because if you have a bunch of contracts all written by different people, they all have different verification keys. You basically, one transaction that calls lots and lots of contracts is effectively large numbers of zero-knowledge proofs that need to be recursively composed together. You need to handle large amounts of data transfer between these zero-knowledge proofs. Effectively, you've got algebraic circuits that you're trying to pretend are iterative programs, and creating a ZK proving technology that can handle that was very, very challenging. But that was just that's just step one. Then on top of that, we needed to come up with an ABI from scratch about how to interpret this stuff. As in, you have a private function call. It's got a bunch of public inputs in your zero-knowledge circuit. You need to interpret those inputs according to some ABI so that your protocol level circuits can figure out what to do. We needed to undertake to figure out how our state trees worked. Even that was non-trivial. How do you do events in an encrypted way? How do you do state sharing efficiently? So if technologies like Zcash, I think they've made improvements recently, but back in the day, same with Aztec Connect. If you wanted to sync to the network, you needed to download every single piece of encrypted state and try to decrypt it yourself to see if you owned it. That doesn't scale. So how do you create a world where I can send you a note where that note doesn't necessarily represent tokens, it represents arbitrary state in a smart contract, and you know that this has happened, and you can decrypt that information without having to sync to the entire network. Again, like that's an open problem. It's until we have much more advanced FHE solutions, there's always a trade-off there in terms of privacy. So figuring out where to go on that trade-off was very challenging. Yeah, that's just the start of it. Then there's how do you even basic things not associated with privacy, like how do you decentralize an L2 network? There's not a huge amount of work on that in the public domain. We had to figure out a lot of that ourselves. Eventually we even realized, for our particular needs, we needed to build in a very small data availability network into our layer 2 in order to secure certain liveness guarantees. Yeah, it's been very challenging. There's a reason it's taken us so long to build this.
One thing that kind of we haven't yet touched on, or you very briefly kind of glossed over it just now, is that not only kind of did you not want to make compromises in the privacy realm, you also told me back kind of like when I last had you on, you're not going to launch this thing without decentralization, right? Kind of like you want a decentralized sequencer and provers. Even if you kind of look at L2 beat now, even the non-encrypted L2s haven't come a very long way there, right? So tell us what you learned on that.
Again, it's all about fundamental incentives. We're not doing this out of some moral crusade. We're decentralized because we need to be. For the same reason why, if you take the internet and HTTPS, where now all requests to website, to a server, they're all made encrypted. They're all encrypted. The responses are encrypted. If all that traffic flowed through one company and one company's servers, they would be the most overregulated company in existence. Because every government agency we go to them going, hello, I would like all your information, please and thank you. Please decrypt it all. For the same reason for Aztec, we can't be centralized. We'd have to build in a backdoor, and we don't want to build in a backdoor. Backdoors are really bad. So we need to be decentralized, where it is a genuine distributed network made up of thousands of different participants that are all collaboratively participating in this network. And so we're one of the few networks that genuinely has an incentive to decentralize. Most layer 2s, decentralization is actually corrosive to their interests, because if you're an EVM, either a ZK one or an optimistic one, your unique value proposition is price and throughput and latency. Basically, cheap transactions, lots of them, instantly settled.
I would contest that, I think. So because in the failure case, that kind of like someone, God forbid, compromise the one multisig that you kind of use to kind of govern URL2, kind of all that value that's kind of protected in there is potentially gone, right?
You're talking about security, which is not a value proposition. It's basically a protective technology. And to be very cynical for a minute, if you look into traditional Web2, traditional software, how often do companies invest in their security? Like not very. If you can spend money to make money, or you can spend money to potentially not lose money in the future, the monkey brain goes, we make the money. We don't protect the future. I'm not saying we have this culture. I'm just saying that this is very common. So, but you're right that there is a desire to use decentralized for that security reason. But it's corrosive to the bottom line for
100%. Yeah. I mean, basically, best business model is being AWS.
Yeah. How decentralized are you if all your decentralized nodes are running on AWS? This is a genuine thing we're covering and wrestling with. But yeah, if you're at ZKL2, decentralizing makes your costs go up, right? Your transaction latency increases, the throughput, like the network throughput decreases, the TPS load goes down. And so there's very low desire to actually make it happen. Whereas for us, we need to make it happen. We can't survive without it. And so we discovered a few things, like even our protocol to select sequences is somewhat novel. There wasn't anything off the shelf that we could take. And you'd think that would be figured out by now. You have a bunch of people who want to produce blocks on an L2, they're staking on L1, how are they selected? You think that gets sorted, but it's not. There's many different views. Then there's just, we've had to do a lot of work on the peer-to-peer networking side, which again, is a bit surprising. We couldn't use anything completely out of the box. We had to do a lot ourselves. But the most interesting one for us was a unique characteristic of Aztec, which is that Aztec transactions, an individual user transaction, contains within it a zero knowledge proof. Right? You have your transaction data, which describes what you want to do, it'll be encrypted, but it's fundamentally still there. But then you have the proof that comes along with it going, my state transitions are all correct. I've followed the rules of your protocol. And in our rollup blocks, we effectively swallow that proof data, right? If you're making a proof of a Aztec block, you are inside your ZK circuit, you're verifying all of the individual transaction proofs, which means when you publish the rollup block, you don't need the proofs anymore, but you need the proofs to make the block, to make the block proof. And we had this dilemma because we did not want to publish the transaction proof data onto L1 because it's large and that's expensive. And we're thinking, well, we don't need to publish it if every block comes with the proof. The only challenge is you need your prover. So you have a distinct between block producers and block provers, right? The block producers are making the block. If they're not publishing the user transaction data onto L1, you need to guarantee that data exists for about 20 minutes so that a block prover can still make that block. And so we're like, oh God, we need a DA layer to make this happen. Like we need a 20-minute DA layer. It's not the most impressive thing in the world. It uses some basic economic consensus, but we had to build that out to make our L2 a reality. And that was an interesting detour we weren't expecting.
So what we've kind of tried to cover and mostly glossed over, because there's a lot of it, is incredibly high level, right? So kind of maybe let's kind of take it down 2 notches. So imagine I'm an entrepreneur building on Aztec. So what choices do I have to make that differ from building on a more standard roll-up like Base or Arbitrum?
Yeah, so if you're building on Aztec, I think there's going to be an assumption that you desire some kind of privacy in your app, or you want to interact with private accounts. What different choices are you going to make? Well, you do have to learn a different programming language and a different technical stack. We figured the semantics around private state on a blockchain are sufficiently distinct that we needed to go the route of creating our own language to make it to basic, so that we could create the abstraction layers that we thought would be appropriate to minimize the complexities of this. It's called Noir, and it's basically heavily inspired by Rust. So if you know Rust, it'll be very intuitive. If you don't know Rust, it's still easy to pick up. It's like any low-level programming language. There's going to be a certain custom, as I said, semantics, keywords that you have to learn in terms of how state is, how to create the state, right? Storage slots, how to manipulate them, particularly when it comes to private stuff. But our docs are constantly improving. I think hopefully by the time that this is broadcast, our latest docs will be. We're going through a documentation revamp, so hopefully that'll be done by then. Yeah. So but the forms of what you're doing should be very familiar. There is a node that you can install to send transactions to. That node has an API that you can interact with. You can write contracts, and those contracts, you define an API that your node uses to get data, and you can connect this all to. You can communicate all of this with a JavaScript wrapper if you want, so that you can write a web application. So the forms of it all are very similar. The details will be slightly different because the state model is different. Like we have public and private keywords in our contracts, which mean they're not visibility specifiers like normal in a regular programming language. They really mean like this can be seen by observers, or it can't be seen. And then these functions can call other functions, and you can commit events. You can do all the similar stuff you expect from a contract ecosystem. There's just a few more keywords that you have to think about because of the public-private thing.
Okay, but so kind of the way that I should think about contracts and gas and wallets and user interactions and so on, that doesn't really change.
That doesn't change at all.
Okay.
It's all the same. We have L2 gas. We call it fee juice. We have wallets in production. The idea is to basically mirror all of the concepts one would be familiar with already in Web3.
Seeing that kind of I have to learn a new contract language, that doesn't particularly daunt me. So I'm a physicist by training, which means kind of I'm a terrible programmer, but I'm a terrible programmer in many languages. So I'm not put off by this. What kind of application do you think it would make sense for me to build first? So kind of which ones do you see where kind of privacy is actually a cool feature rather than an afterthought? And kind of I think what I'd like to talk about next is kind of performance. So kind of like the trade-offs you kind of make for this.
So yeah, I'm also an ex-physicist, so I can relate. Hopefully over the years I've become better at certain programming which I used when writing code for Aztec.
What do you mean I can't do this in Python? I can do everything in Python.
Yeah. Yeah, or in my case, Fortran. Oh my god,
You don't look old enough for this. Okay.
This is gonna be kind of backwards,
This is true. We can be very backwards.
The applications that make sense are varied, but generally they will revolve around two things. Either you will need an understanding of a person's identity that requires disclosure of sensitive information, or you want to, more broadly, you want to create an application that's based around information asymmetries. You want an application where you're interacting with somebody, a third party, like a counterparty, and your counterparty knows stuff you don't, and you know stuff your counterparty doesn't, and you don't want to disclose it. I know that's very vague. Some of the low-hanging fruit for that is games. To give an example, the original breakout NFT from 2018, I think, was CryptoKitties, which was all about, you have these cats and you can breed them. You can combine them with other cats to create new cats with different traits. And back then, what they relied on was code obfuscation, basically. They didn't publish their source code. And so it was hard to figure out ahead of time how to breed cats to get the optimal desired traits. Nowadays, that won't work. That kind of stuff gets instantly reverse engineered because the overall skill level is much higher. But you could use privacy to actually make sure that you couldn't. You could use things like random and some randomness to basically make it so that only at the conclusion of your transaction will you understand exactly what traits you're getting, what algorithm was run.
I like where you're going with this. So kind of like when I ask you, so what do you think is the most pressing application to build on top of this? Oh, but we can breed private CryptoKitties. This is fantastic.
You did not say most pressing.
Sorry.
Is this going to solve all of society's problems? Absolutely not. But it's relevance. And there'll be demand for that kind of thing on chain.
No, I think kind of like games in principle, kind of like old school games, I think they're actually pretty good examples because they actually use very little state, right? Kind of like if you look at kind of like these 80s arcade games, kind of like they're tiny. So kind of running them in this kind of environment, kind of I totally see where you're coming from.
More useful stuff would be for Web3 native utility would be some basic identity protocols to protect against for Sybil resistance. Basically, proof of uniqueness, so that you could do things like airdrops that can't be farmed by somebody pretending to be 1,000 different people, or if you want to do a sale of tokens, for example, and you want to ensure that it's only one person coming purchase, or governance. So let's say you want to do a vote on a DAO, but you want to use quadratic voting, where the more tokens you have, like the less the marginal voting power of your additional tokens. There you need Sybil resistance. You need to ensure that one voter that can only vote once, instead of pretending to be 100 different people with smaller balances, because otherwise you can game quadratic voting. And so Sybil protection, basic identity protocols, I think will be very, very valuable. Things like ZK Passport, then that can be expanded to do finance that exists in regulated spaces. So if you need to prove somebody's not on a sanctions list, for example, or maybe you need to prove transaction limits so that somebody is not transacted above a certain threshold in a time period. or you need to know that somebody's resident in a certain country, things like that, where you can basically add in identity credentials to build out DeFi protocols that interact with assets that are more originating in the real world. And again, I think this is also one of the reasons why one of the original use cases of NFTs didn't take off. NFTs originally, people were like, well, what is this for? Tickets, because Ticketmaster is charges very high fees. Ticket agents tell Aztec, it's like, why can't I get rid of them? Well, because one of the reasons is that to make that work, you need to link an identity to a cryptocurrency account.
Yeah.
In a transparent world, if you have identity protocols, that's no longer such a challenging thing to do.
I 100% concur that that would be incredibly useful and kind of like barring kind of like all potential attributes of your person to kind of like whoever kind of like you want to buy a bottle of wine from. Obviously doesn't make sense. But if you look at the way that these regulations are drafted, typically proving that you are above 18 doesn't cut it. So typically you kind of actually, as the person selling the bottle of wine, you actually have to have some sort of copy. So how do you get around that?
Well, a couple of things here. First of all, there's a lot of value in adding identity to things that are not, it's for functionality, not regulatory compliance. Things like, Sybil resistance for airdrops. Then there's I think the more mainstream your use case, the more unnecessarily regulated it becomes. To be fair, these regulations were not drafted by people that knew about zero knowledge proofs. So the idea, when people were drafting here, proof of age laws, God knows when, 1950s, right? Like the idea that you could prove your age without seeing. I'm selling wine. I know somebody's 18 without actually seeing some identity. That was just inconceivable to them. So I do think there's there's some advocacy work that we're doing. I do think that legislators, politicians they're actually becoming more aware of zero knowledge proofs. And this will change. I do think there's plenty of regulations that are actually very amenable to zero knowledge proofs already. Things like using ZK passport, particular passport proofs, because e-passports are already a thing. There's already precedent that for them to be used in things like passport gates. There's already a well-established understanding that these are very strong credentials. You also have a lot of precedent from the document signing world, where digital signatures on documents can be as good as the real thing. And so you can kind of combine these precedents to make claims that some of these some of these ZK-based identity solutions are good enough. Obviously,
yeah. I mean, if DocuSign can kind of check that box, then obviously, I mean, kind of like that there was some impressive lobbying going on there to kind of make anyone agree that this is kind of definitely the same thing as signing something in wet ink, like clicking, yes, this is my name.
Yeah, and I mean, different jurisdictions will progress at different speeds. For example, the US is already in the process of passing several crypto regulations, the Genius Act, there's the Crypto Markets Act. It's got a fancy name. I can't remember what it is. Europe will be much slower, to be very blunt. We're not really
we always are slow.
If you want to do some advanced enterprise privacy stuff, we're not talking with the EU people right now, because Europe will be very slow. Nevertheless, there is value there. There's some things you can do within the existing frameworks, but really it's America's taking the lead. There was an opportunity for other countries to take advantage of America's conservatism under the Biden administration. My country among them. There were many voices advocating for what could be done and the value that could be generated. And now these countries will deal with the consequences of inaction. The economic center of gravity for crypto will be America. And that's just the way it is.
Tell me about the performance trade-offs for programmable privacy. So is kind of like, what's the bottleneck right now for performance? Is it the proving, or what kind of constrains me?
Proving is more of the user experience bottleneck than the performance bottleneck, because your user makes the proof, then they send it to the network. But when it comes to transaction throughput, the amount of time it takes for the user to make the proof doesn't really matter, because you can have large numbers of people making proofs at the same time. For network throughput, right now we are targeting for our very first release on the Ethereum mainnet, we're targeting a whopping 2 TPS, which does not sound like much. However, if you look at the throughput of existing L2s and how much they're being used, 2 TPS is actually quite more than enough. It's fine. And over the next 12 months post-launch, we'll be scaling that up to 100 TPS. Some of the bottlenecks are, well, there's a lot to prove in a rollup, in a ZK rollup, particularly because we have something I didn't even mention until now. We have a public virtual machine, a ZK VM. So for all the public things that you're doing, like public functions, public transfers, they're all proved via a ZK VM that's proven server side. There's some performance challenges there, particularly with like how much can be parallelized, how much can be serialized, how much is serial. We have issues with our peer-to-peer network throughput, bandwidth throughput, because every user transaction is accompanied by a zero-knowledge proof. And so in your peer-to-peer network, to get that transaction into the mempool, you need to propagate this information. And your peer-to-peer network throughput will be substantially lower than the bandwidth of your node operators. And so the zero-knowledge proof size there actually is quite important. So right now it's about 50 kilobytes, and we have some work scheduled post-launch to get that down to 4. So that's work that needs to be
To 4 kilobytes.
Yeah.
Okay.
It's not a hard problem. It's just time consuming, so we haven't done it yet. Using multi-polynomial, basically instead of committing to one polynomial, like one commitment per polynomial, you just have one commitment for lots of polynomials. And then there's just generally our node software, because we built everything from scratch. Because we had the semantics from private state was so different. We have this thing called the private execution environment, which doesn't even exist in other networks, which handles private state syncing, state retrieval, zero-knowledge proving. We wrote this all of our node software in TypeScript so we could rapidly prototype, but this is not a performant language. So there's huge amounts of engineering work to do to improve our performance. Like to get from 2 TPS to 100 TPS, most of it's just pure engineering, taking something which is brand spanking new and just applying traditional software engineering optimizations to it.
One rule of cryptography or applied cryptography is you never build your own systems, right? And it seems like you've built all the systems. Are you worried about that?
What rule? No, I'm not. That's a stupid rule, in my opinion. The rule is don't roll your own crypto. Right. Well, then who rolls crypto if nobody does it? Oh, experts. Who the hell are the experts? Self-appointed. That's who they are. But
Well, I mean, everything that's kind of like you want to use things that are battle tested as much as you can, right? And I understand that kind of like sometimes building novel things kind of means having to build new systems, but trying to possibly fall back on proven systems.
there's no such thing. There is a fallback. We are the first. Aztec will be the fallback for future generations of private cryptography. There is nothing else. So we didn't have that option. If you are building your own cryptography, there's dangers there. The typical canonical business of don't roll your own crypto is targeted towards software engineers that don't understand cryptography. They're not like, so what's the barrier? If you want to roll your own crypto, well, step one, you need to do your own original research. You need to publish it. It needs to be peer-reviewed by cryptographic experts. You need to secure it. You need proofs of soundness. You need proofs of completeness. You need proofs of zero knowledge. They need to be widely accepted and understood, and they need to use security assumptions that are like widely accepted. So you could probably get away with the algebraic group model, just about, but nothing weaker than that. And then you need to so then you have the theory down, then you need to implement it in software. Now software needs to be audited internally and externally. Then what you have out of that is you have an insecure system which might work. It will work. Because as you said, the only thing that really guarantees the strength, the security of cryptographic technology is time. The fundamental assumptions that we base our security proofs around are actually not known to be true. We do not know that the discrete logarithm problem is hard. We just assume it is because no one's figured it out yet. And so we are taking a very security conscious approach to our launch. I say we're going to be launching on the Ethereum early next year. What that is going to be is we're calling it the Aztec Alpha, because we will not be under any illusions that this will be secure. We will have done our best efforts. We would have gone beyond all reasonable doubt attempts to secure this network with our internal external audits. But any software engineer will tell you it's not possible to write secure code. It's just not. It needs to be battle tested. There will be bugs. Those bugs will be found, hopefully by white hats. Because of our generous bug bounty, we will fix them. But the messaging when we launch will very much be security conscious. The messaging will say, this is not secure. Do not put too much money through this. Don't put in any money you're not prepared to lose. And we're going to have a checklist of things that need to happen before we're willing to consider the network more secure. we're going to need to not have any serious or critical bug reports for 3 months. We're going to need to have something like 99% network uptime for 3 months. And once we pass these criteria, then we will consider the network to be in beta. And once we hit beta, we will be much more comfortable making claims about its security. We'll be much more comfortable with people putting large amounts of funds in. But until then, it's going to be a risky protocol just because of the nature of what we're doing and because it's decentralized.
There's a lot of fasts here. You already kind of talked about this a little bit earlier, kind of the bandwidth issue with kind of submitting the proofs as well as kind of the generating the proofs. How much do you worry about latency for use cases? So kind of like when you kind of say this is great for games, kind of obviously a lot of games rely on fairly low latency, right? You don't want to wait for an hour for your opponent to kind of make their move.
The latency will be good for a large variety of use cases. We are targeting 12-second latency. So we're not producing blocks every 12 seconds, but because of our proof of stake network and the fact that we have our own little DA layer and things like that, we can guarantee fairly strong guarantees, you can get finality on 12-second time limit, where at that point, that is a line they'll get slashed. And so there's there'll be a few $1 million of value backing that claim. Is that good enough for everything? No. Similarly, but at a fundamental level, the problem is that if you're sending a transaction across a layer 2, you're paying for the highest security guarantees. You're paying for the highest like liveness, sensitive resistance guarantees. And there's no market for security. It's not like you can choose to pay less if you don't care so much. And so the solution to this, in my opinion, is the L3 thesis, application-specific rollup thesis, something that we are, post-launch, we will be aggressively building out via the Aztec stack. Basically, imagine a scenario where you can write an Aztec smart contract, and it's all the same as a regular Aztec smart contract, but when you go to deploy it, you're not deploying it to the Aztec network, you're deploying it to a rollup that's hosted locally or hosted on NS in AWS. But basically, it's a network where there's only one sequencer, it's not decentralized, there's no data availability guarantees, you just trust the sequencer. And in that kind of model, you can get very fast throughput, very low latency, particularly if your transactions are all private, because if they're all private, you're not modifying any shared state. So your transactions don't have any race conditions. And the only serial part of the transaction is recomputing your state trees, but everything else is fully parallelizable, so you can make blocks very quickly. And this L3 component will be very, very valuable for low value, high throughput use cases, things like micropayments, things like gaming. That's how we plan to solve the problem.
Okay, that also kind of solves your 2 transactions per second dilemma to some extent. How do you think about state growth and storage in a world of encrypted data?
Yeah, it's challenging. You got to shard it. Basically, the state tree only ever grows in a private network, right? Because when you delete a record, you're not actually deleting it. You're just creating another record that says this old thing has been deleted. And you do it in a way that you can't link the two. So data proliferates much more rapidly on a private network than a public network. And there's no really great solution for this right now, other than basically you do sharding. You have state epochs where, let's say, I don't know, like maybe a gigabyte, terabyte of state per epoch. And whenever you're performing state transitions, you're specifying the epoch of your node. And so this leaks a little bit of information, because if you're modifying a really old node, people know you're modifying a really old node. But it's kind of the best we can do right now without requiring nodes to consume enormous amounts of data. There's obviously, so there's sharding. You could do like the full Ethereum Foundation sharding desire, but that's challenging. I'd prefer if somebody else does it. I'd prefer if Ethereum does it. But right now, it's a bit beyond us to build that all out from scratch.
Cool. So kind of like, I hear that. I think kind of like not building everything is often good advice.
Sorry, can I be annoying and interrupt? Another thing, sorry, I just realized sharding doesn't work for us because if you have just one giant database, even if you shard it up, if I want to prove that my node exists in that database or prove it doesn't exist, I need to create a Merkle proof, which requires knowledge of the entire data set. And that's the problem. You need to be able to do inclusion and non-inclusion proofs over subsets of your data. And that requires what I call sharding, like splitting your state into epochs and revealing a small amount of information about your nodes. the age of your nodes as a result.
There are a couple of competing privacy-based chains. So kind of if you look at systems like Alio or Narmada or ZK Sync's privacy layer, how do you mentally categorize them with respect to Aztec?
Privacy is a hot narrative right now. And it's also a very poorly defined word. And so what people say, what they mean when they say privacy varies. And so obviously I have my own biases here. I don't want to throw shade around. Things like the model, we'll see about them. I think that they have a very ambitious goal in mind. I really they're the ones that use FHE to create like a fully encrypted Ethereum. There are certain challenges with FHE that are yet to be satisfactorily solved. Otherwise, we'd use it. So one of them is if with FHE you can. So okay, with ZK I can prove anything about my data. With FHE, I can give you my encrypted data, and you can run a program on that data, and you don't know what's going on. You can't do that with ZK. So it's much more powerful in that context. However, it has two very big flaws that need to be resolved. One of them is the data is all still encrypted. And so if you want to just take a regular EVM and make it all encrypt all the data and then use FHE, then the problem is who owns those decryption keys. You need a multi-party computation network to hold that, partial decryption keys for your state. If you have that MPC network, then you can also use that MPC network to do zero-knowledge proving via secret sharing. This is what Tetseo do. You get very similar outcomes both ways. The whole who holds the decryption keys, how do you do key rotation, make that secure, is very challenging. And we'll see how they execute on that. I do hope they are successful. I think that right now any privacy solutions that offer genuine privacy, it would be good if any of them were successful. You have things like ZK Sync. What they're doing is very different. I would not call what they're doing privacy by any meaningful standard. The way that they get privacy is that you run you run an L3 and people send transactions to you, and you don't broadcast anything about that L3. So the way that you get your transactions is not through a public network, it's through private information, private messages. And then when you make your rollup proof, you basically discard all of the information around the data in your rollup, and then you put that rollup proof on chain. Is that private? Well, yes, it's the same with a private server as private. It's not a great way of creating a composable ecosystem. The thing that I think is most valuable about privacy is composable privacy. The idea is you can write a private smart contract, I can write a private smart contract, and these things can talk to each other. They can call each other, and that's we don't have to share any information with each other. Our users don't have to share any information. It all just works out of the box on a public network. You start getting into some very, very gnarly trust assumptions if you want composable privacy on a network like ZK Sync is building, where everything is run by one server and that one entity sees everything and nobody else does. It's a huge amount of trust you're placing in that person. But it is useful for certain use cases. It's useful for enterprise. It could be useful for gaming. It's useful for where the trust assumptions are very low. But yeah, and then you have other teams like Alio and Mina that are basically doing the ZK route that we are. There, it's an execution play about whether this stuff can be made performant enough, easy to use, whether you can create the right abstraction layers. And right now, no one's really cracked that problem. And I can't claim that Aztec's cracked it. We're not even launched yet. I hope we will, but nobody has yet. I'm convinced, as a matter of faith, that privacy is useful, that it's needed, that if you make it easy enough, people will build on it. Not because users care about privacy as a feature, but because it's a required property for a lot of valuable applications. It's a question about building a technological base layer that's competent enough to provide the developer user experience that people require.
Aztec is an L2 on top of Ethereum, and kind of the decentralized world has shifted since you decommissioned the last version of Aztec. How do you think about the benefits of being an L2 on top of Ethereum rather than, say, a standalone L1? I mean, you already have the decentralized sequencer set. You could just be an L1 and kind of not pay for living on top of Ethereum, no?
It could, but then there are other problems with that. Specifically, privacy doesn't matter if you don't have any value you want to keep private. Nobody cares how many magic beans you have. They care about how many US dollars you have, or your property, or like who you are. And so you have a very big chicken and egg problem if you're running as an L1. Whereas how do you get value into your ecosystem? Because it's completely new, it's set up from scratch. Like obviously you can do bridges, but bridging is still a fairly complicated process with an unpleasant user experience. And ultimately, yeah, we thought the risks would be too great. And also we do gain a lot from building on top of Ethereum. Like we don't have to roll our own consensus network from scratch. There is a slightly lower maintenance overheads to our software because of that. I was hoping at the start they would be much lower than they are. But yeah, we've had to build a lot out ourselves. Ethereum is still the canonical source of assets on chain. If you want to issue an asset, okay, you can do Solana and things like that. But if it's a chunky asset with a lot of value in it, you put it on Ethereum. And we wanted to be able to make it so you could very trustlessly bring your assets into Aztec from Ethereum, because in the same way that Ethereum is the canonical source of assets, our goal for Aztec is to make Aztec the canonical source of credentials. Effectively, if you have a token or an attestation that says something about you, or what you've done, or what you want to do, the natural place to issue that is on Aztec, where it's encrypted by default, and you can selectively disclose parts like that credential to either people or to smart contracts. And yeah, we felt Ethereum was the right place to do it because it's where the money is, and privacy is not useful without money. More generally, we do think that bridging, like making it very easy to get transactions into and out of Aztec from any other network, for us is extremely important. We don't want to just be tied to Ethereum because there's a very unique value proposition for Aztec that no other L2 faces. It's not a secret that most L2s are somewhat parasitic to their host networks because the L2 wants its own set of liquidity, its own tokens, so that you can build applications on the L2. And that liquidity comes at the cost of taking it out of the L1. With Aztec, it's very different because there is unique value in bridging not tokens, but information between Aztec and other networks. For example, imagine you're building some kind of trading marketplace on Solana, but you need a level of compliance. Maybe the assets, you need to know that people are not on a sanctions list on Iranian. Maybe you need to understand if someone's American or not, things like that, some basic compliance. Well, what you can do is you could send a request into Aztec, where that request will check some encrypted credentials on that person, and the request responds with either true or false, like yes, they're compliant, or no, they're not. Solana, that application on Solana has gained something of value from interacting with Aztec, and the Solana network has not lost any tokens. Effectively, you get a privacy shield for free, for a very low cost. And that's the direction we want Aztec to travel in the future. We want it to be the universal privacy layer for all of blockchain, and we want to execute on that in a very positive sum way, where the canonical method of interaction with Aztec from other networks is not you bridge assets into Aztec and then they stay there, is you bridge identity information into and out of Aztec. Or maybe you put tokens into Aztec so that you can create, so that you can perform private interactions with them, but then very quickly they go out back into the parent network. We think that's a much more kind of positive sum way of interacting with the ecosystem where everybody wins.
I 100% concur on the message passing use case. So kind of like if you were to kind of use it as an identity layer, 100% agree with everything you said. If you look at how assets are actually issued in the Ethereum ecosystem today, I know that kind of like back in the day, we talked about assets natively being minted on Ethereum mainnet and then kind of being bridged into L2s, and then kind of things happen on L2s, they get rolled up, and then kind of like you bridge out of the L2 onto mainnet again. What we effectively see is that kind of like the assets are born on L2s, they live on L2s, and they die on L2s, and ideally they're happy on L2s, but kind of they don't, and kind of like for anything that is natively minted on an L2, the L1 doesn't actually give you any security guarantees whatsoever, right? So kind of like all the security you inherit from being an L2, you only inherit for bridged assets from mainnet, right? And I think to some extent we've seen that play out differently?
When you say that you don't get any security from the L1, I think this is largely because these L2s are centralized, and so you have this kind of the weakest point of failure is something in the L2 like a multisig or something. It's a bit different for Aztec, where you have sequences staking on Ethereum L1 to be a block producer, and once a block has been produced and you've updated your state root, then you are very much relying on Ethereum's consensus to define what the canonical version of Aztec is. And so I do slightly disagree with the idea that you don't inherit anything from any security from Ethereum. I mean, we are targeting to be a stage 2 rollup on launch, where that is kind of the point.
But say I kind of deploy some sort of token on Aztec directly, right? I can't force exit to Ethereum, right? I can't. But that asset that kind of like Ethereum knows nothing about.
So the way we do it is we call it an escape hatch, but basically for a certain fixed amount of time, for every block production epoch, anybody can send rollup transactions. It's not just a sequencer. It's basically a free-for-all. The idea is we don't intend for this to be used, but it can be used. If you're getting censored for some reason, you can use that window to make your own Aztec transaction to exit. If for some reason there's something catastrophic failure state and like no bonds producing blocks, then you could use that to produce your own blocks and get out of Aztec. So no, you can force exit onto Ethereum.
But can I force exit an asset that was not minted on Ethereum?
Oh, it wasn't minted on Ethereum. Oh,
it's minted on Aztec.
Yeah. Okay. In that case, yeah. If you've minted on Aztec, then you can't force exit. Because it's like an exit. So I get what you're saying, that the security guarantees you get are kind of it's a combination of Aztec and Ethereum, where like the weakest security holds.
And the way that users behave is all kind of the way that and when I say users, I kind of mean application developers, kind of is assets get natively minted on L2s all the time now. So kind of like if you look at the values that kind of get transferred on L2s, kind of the minority of them have actually been bridged in from L1. The majority of them are natively L2 assets, and then you have no security guarantees.
But the majority of value is not on L2s. As in L2s, most L2s don't really have product market fit, and so most of what's going on is synthetic. It's liquidity farming. It's incentive based. It's basically nonsense. And so I don't think it sets a very useful precedent for a network that has the useful economic activity on it. You're right that yes. So what happens in L2s is you get these synthetic meme coins that get produced, and it's all on L2s. Does it matter? I mean, do you need ironclad security for a meme coin? No. So I don't see this as a problem. I think that for Aztec, it's fairly clear, I think, how things are going to play out. If you have an asset that requires identity checks, regulated checks, it's going to turn off on Aztec as a native asset. Is that secure? Well, yes, because we're fully decentralized. We're going to have an enormous amount of stake backing the network. The more economic activity the network generates, the higher the fees, the more incentive there is to put more stake onto the network. So I'm not worried at all about its security. What I don't want to see happen is that Aztec starts becoming like very parasitic to Ethereum.
Yeah, I hear that. I think that's commendable.
Because I think that the value proposition really is with bridging information. I think that ideally the only time an Aztec is natively minted on Aztec is if you can't put it anywhere else, because it requires privacy checks, composable privacy checks that you get on Aztec. I don't see Aztec as being a very popular home for like low latency meme coin trading, because it's going to be more expensive and slower than fully transparent networks. So I do think that there's always going to be, I mean, obviously there'll be some of it. You can't stop it. It'll happen. I don't see that as being a particularly dominant use case on Aztec, unless we've completely failed to execute on any of our privacy. Unless all of my thoughts about privacy was wrong, then that's the only way that world will happen.
Maybe let's zoom all the way out to kind of like past all the crypto stuff. If you kind of look at the world right now, kind of we're dealing with declining expectations of privacy, and kind of like you see that in the UK, you also see it in Europe. So kind of like chat control is something that only recently failed. How do you see that shift? And do you think kind of that level of cryptographic privacy can play some sort of role in reversing it?
Yeah, it's a tricky one. I noticed two trends which utterly confound me because they seem to be at work, like they seem to be mutually incompatible, which is that Western societies are becoming more and more distrustful of their governments and like less confident in their ability to execute on implementing effective state policy. Yet at the same time seem to be more and more willing to give those governments powers and control over their private data. Part of this is like how do I put this? Privacy is not a mainstream narrative, and people don't think very much about it. I don't think this means necessarily people don't care about privacy. They don't care about government overreach. It's just that it's not part of the kind of the canon of ideas that they consider important or contentious. To give an example about this, right, the UK has recently passed a very unpleasant surveillance bill called the Online Safety Act, ostensibly to protect children, but in reality is, I would argue, is a massive curtailment of free speech online. Does this mean people don't care about government overreach? They don't care about privacy? Well, maybe not, because at the same time, the UK government is trying to introduce identity cards, which is met with overwhelming popular opposition. People hate that because identity cards are they're more familiar with that as part of the concept of ideas they have, right? They think identity cards, they're familiar with totalitarian states using those to restrict people's movements, exchange of ideas, information, and they don't like it. They're not familiar with how governments use online surveillance laws to repress free speech or limit free exchange of ideas or make their personal data more secure and more likely to be leaked. This will change in time. I think that what's going to happen is more and more oppressive legislation is going to get passed and it's going to be abused and manipulated more and more. And eventually we might see some kind of backlash. I think that there's always my hopes here when it comes to these things that lies with America. I don't think, whilst you're getting some annoying age restriction laws at the state level, they're not the same as chat control, for example, where it's just a very, very clear power grab by the state bureaucracy. I think basically America will always be basically demonstrating what the alternative of if you don't have controls over speech. Eventually, it'll just become a very compelling differential. I hope.
But I mean, just to push back here, so kind of in some way, the US are a nation that is most advanced in surveilling their own subjects. And it's also currently a state where you can lose your visa for kind of being holding a non-majority opinion, right? So kind of like it is very kind of anti-free speech in some sense. No?
I'm not going to hold America as a bastion of liberal values anymore, for sure. Like there is an element of capricious state policy. I think you've also seen in America the degradation of the rule of law. We've even seen that with crypto, right? Where under the Gary Gensler regime, they tend to criminalize crypto without passing legislation to do so. And then under the Trump regime, it's a free-for-all. However, I do think that part of America's strength lies in its decentralization, as in you don't have a particularly strong unitary authority that can exert massive amounts of control over people's lives, like you do in most European states. I know Germany is slightly different with this federal structure, but most European states are unitary entities where the government says, hey, we're going to surveil you and look at and create an unwarranted financial surveillance regime, and there's nothing you can do about it. And if you think that and if you complain, we're going to just call you a child molester. This is hard to do in America because you have state governments that generally have political incentives to push back against the federal government. When it comes to things like online surveillance, it's actually the state governments that are the ones pushing it to perform age checks and other content. It's a very mixed landscape, but as a core cultural value, America does value free speech, regardless of what the laws say. The laws say they value free speech. You'll see that getting eroded for people in out groups, immigrants, people on visas, but I don't think you'll ever see a world where the American people as a culture will say, yes, we were willing to curtail free speech to gain safety. That's not going to happen. Whereas I think in Europe and in the UK, that is currently a debate that's happening, and you have very powerful factions pushing for less acceptance of free speech and more acceptance of government's oversight over what people are saying. And I think that is very, very concerning.
Cool. Thank you for coming on again, Zac. I hope you're right. I mean, I share your pessimism with respect to Europe. I don't share your optimism on the other side of the Atlantic. But yeah, your word in God's ear.
Thank you. Just to be clear, I mean, I'm normally based in the UK, not America, and I wouldn't say I'm optimistic on America. It's just that I think that it's more likely to preserve, like, it's not moving in the right direction. It's just moving in the wrong direction at a much slower pace than the rest of the world, if that makes any sense. I'm not sure I call that optimism.
Cool. Thank you, Zac.
Thanks a lot.